Now we're going to go into example 2. It tells us to plot and connect the points -8, 8, -2, 5, and -7, 2. Then give the best name for the polygon and determine the area. So I'm going to go back up to the coordinate plane, and I'm going to plot those 3 points in the proper places. Alright, so we have E at -8, 8. We have F at -2, 5. And then we have G at -7, 2. I'm going to connect those points in order. And I can see that we made a triangle. Now, the kind of triangle that we made here is an acute triangle. We could use the equation area equals base times height divided by 2 if we know the base and the height. Well, here's the problem with this particular triangle. Notice that the base and the height, whichever ones they would be, are not either horizontal or vertical. All of those lines are diagonal. So that means we can't just count the spaces between the endpoints. We have to do another problem-solving strategy. So what we can do is, in this case, we can draw a box around the triangle, draw a rectangle or a square. We notice that E is the leftmost point. I'm going to draw it so that it's perfectly horizontal all the way till it's even with F, which is the rightmost point. E is also the highest point. So I'm going to draw that down till it's equal with G, and then I'm going to finish my box off. Now, to make this a little easier, I'm going to color in the triangle that we're going to find the area for. We're still finding that area right there that I colored in. But now what we can do is, since we drew the rectangle around the triangle, is we can find the area of the rectangle and then subtract away the outside triangles. I'm going to call this triangle A here, this triangle B, and then this one here I'm going to call C. If we find the area of the rectangle and subtract away those outside 3 triangles, what we should have left is the area of the inside triangle. So I'm going to label my work here rectangle, triangle A, triangle B, and triangle C. I'm going to list the equations that I'm going to need to find the area of each of those. A rectangle is length times width, and then the triangles are base times height divided by 2. Now, in order to calculate those, I'm going to have to figure out the dimensions of those. I'm going to go back up for my rectangle here. My rectangle, the dimensions are vertical or horizontal, so I could say that I have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So I can substitute 6 for the length and 6 for the width and get an area of 36 square units. Now for triangle A, remember, you got to go from the corners, where the corners meet in the green triangle, to the corners of each triangle. So here's the right angle in triangle A. That tells me the base is right on here, 1, 2, 3, 4, 5, 6, by the height, 1, 2, 3. So I'll substitute those in there. 6 by 3 divided by 2, I get an area of 9 square units for triangle A. triangle B, I'm going to go from this corner where the green triangle meets it to the corner over here where the right angle's at. So I have 1, 2, 3, 4, 5 by 1, 2, 3. Substitute those in there. I get 5 times 3 divided by 2. That tells me the area of that particular triangle is going to be 7.5 units squared. And then the last triangle, triangle C, I can see that there's the right angle. So the base is right here, 1 by 1, 2, 3, 4, 5, 6. Got to go all the way to the corner where the corner of the triangle would be. So I have 1 times 6 divided by 2. That tells me the area of that particular triangle is 3 square units. Now to find the total, I'm going to have my rectangle 36, and I'm going to take away a 9, a 7.5, and a 3. And subtract away those outside triangles. And when you do that, you get a total of 16.5 units squared. So if you think about it, this entire rectangle that we have here is 36 square units. If we take away the area of triangle A and the area of triangle B and the area of triangle C, if you take those away, you're left with the area of the inside triangle.